All right, so here you go. Pressure of gases. This is what we talked about already, right?
Yes, ma'am.
So, pressure is caused by what? Particles, but doing what?
Stuff. Sliding
Stuff.
forward.
Does it make pressure when a particle hits another particle?
Yeah. Yeah.
Does it make pressure against the walls when you throw two balls inside the room and hit them against each other? If two balls hit each other in a room, they don't cause the walls to fall down. They don't, do they? They don't dent the walls. Pressure is caused by particles bumping into the walls. Now, are they going to hit each other too?
Yes.
Yes, of course they will. Probably the more bumping into the walls is happening, the more they will hit each other also. But the point is that the reason for the pressure is because the particles are bumping the walls, not because they're hitting each other. Does that make sense? All right. Here's the next one. Well, you did this, right? If you increase the volume, what happens to pressure?
Goes down.
Goes down, which the fancy word for that is decrease. And another word for volume is space.
Space.
Y'all need to settle down. And then this is really still continuing the same one. If you increase the volume, the pressure decreases. Why? They find the walls what? There's another part of that.
Farther away.
Farther away. Find the walls farther away.
Or
You're thinking the right thing, I think.
yeah.
How do they find the walls?
They go exploring. Oh, okay.
Does that make sense?
Yeah.
Yeah, they find the walls less often.
What? Find the walls.
Because if I put you in a big room and tell you to find a wall, it's going to take you longer to get there than if I put you in a tiny room, right?
Yeah.
Now, of course, are particles like intentionally going around looking for walls? Do particles have brains? No. But they do hit the walls more often or less often. All right. It goes the other way too, right? If we decrease the volume, what happens to the pressure?
It decreases.
You decrease the volume, the pressure is going to increase. And why is it going to increase?
Because they find the walls more often.
Because they bump. I put bump this time.
Okay.
Yeah, same thing though, right? They bump the walls more often. Is this pretty simple and easy?
Yeah.
You like this? I love how common sense this is. All right. And then just a little picture of the graph here. Some of you make sure that you should have this already. You may not need to really draw this because you already have this, but I drew it because I didn't make a graph. Okay. But it's important to recognize that the graph is a curve. It is not a straight line. Because it's a curve, we are not going to be doing a great deal of like the math to figure out these things the same way. We will do some math about this, but it's going to be a little bit different. We're not going to be like kind of, I don't know, estimating how these things are related quite the same way. We will, but it's going to be a little different, but kind of the same. All right. We never get down to zero volume though. Why not?
Because it's not possible.
But why not?
Because it would,
But what?
because it would explode.
It would explode.
Or
Wait, why would it explode?
Because of the pressure.
it would.
Because what, Josh?
Because there's nowhere for it to
It's
go.
too high.
There's nowhere for it to go. What did I write? I wrote down because the particles take up some space. There is, in fact, a limit to how close together you can push them, right? Which I think that's kind of variations on what y'all just said there. You can't actually push a particle beyond a certain point. Kind of like you, right? You can squeeze inside a box, but only so big of a box. Or so small of a box. All right, and then what about, you can get really close to zero pressure, and then we kind of had a whole discussion in this about this line in another class, but we're not going to deal with that anymore. The important thing is you can't get down to negative pressure. We did talk about that. Why can't you get down to negative pressure?
Because they don't pull.
Because what?
They don't pull.
Ruby.
They don't pull each other. They can only push.
Right. Pressure is particles bumping, not pulling. Maybe I should even add that in here. If particles could pull, then perhaps we could think about negative pressure. But particles can't pull because they have nothing to pull on. They're just little balls running around.